Welcome back to Aurora Tech Channel. Today, I will be reviewing the Sovol SV05. When I first received the review request from Sovol, I thought it was just a cheaper version of the Ender-5 Pro that cost $299. Surprisingly, however, instead of removing features from the Ender-5 Pro, the Sovol SV05 actually added more features and made some improvements. Let's take a look at what these two machines have in common. They both have the same extra sturdy box frame, the print bed moves up and down to work as the Z-axis, and the Y-axis is controlled by one stepper motor and uses a dual shaft. They both come with a classic LCD screen, mechanical limit switches, a single Z-axis, the same Creality V4.2.2 motherboard, and the same spool holder, as well as other small parts. The Sovol SV05 added a Creality CR Touch auto bed leveling sensor, replaced the Bowden setup with a direct extruder, and added an anti-backlash spring-loaded nut on the Z-axis. There are also two arms made by injection molding to provide better support for the print bed. Besides that, there are some improvements with cable management and the location of the screen. It looks like these are the upgrades that most Ender-5 users wanted to be added to the printer, so this $299 SV05 looks pretty good to me in terms of value. I would like to thank Sovol for sending me this machine to review, and with that, let's get started. We have the base frame, the top frame, the Z-axis frame, 4 20x40 extrusions, the print bed, the power supply, the case for the motherboard, the screen, support arms for the print bed made by injection molding, and some tools alongside the manual. First, take the 4 20x40 extrusions and secure them to the base frame. Then, place the top frame on top of the 4 extrusions and secure it. Next, install the case for the motherboard at the bottom right corner at the front of the printer. Install the Z-axis frame at the back of the printer, and we can then secure the print bed right on top of it. Install the 2 support arms for the bed, install the power supply and the screen, and then connect all of the cables. As for the filament holder, the manual tells you to install it here at the side. I'm just going to install it at the top instead. To ensure that the print head doesn't bump into the filament holder, I only used one T-nut on one extrusion. I will also remove the Bowden tube and the coupler so the filament cannot be directly fed inside, making it more convenient. Okay, we can now turn on the printer. I will start by manually leveling the 4 corners, then setting the Z offset, and doing auto bed leveling using the CR Touch auto bed leveling sensor. Insert some filament, which in my case is Creality Blue PLA, and I will start the first test print of an XYZ Calibration cube, which was already in the SD card. It seems the orientation of the cube is wrong, as the X and Y positions appear to be flipped. Other than that, the rest of the print has no issues. The layers look great, most likely because this printer is not a bed slinger, and the dimensions are also accurate. Up next, using the same filament, let's print a 3D Benchy. The result is pretty good. The cooling and overhanging both look nice, the layers look great, and although there is a tiny bit of stringing, the Benchy has no other issues and is a decent print overall. Let's go to Cura to slice our next print, a bigger print of a Spiderman model. We can just use the Ender-5 profile, as these printers are pretty much the same. The only thing we need to change is the retraction distance, as the Ender-5 Pro is a Bowden setup and this is a single gear direct drive. I will follow the DIY Ender-3 direct drive extruder and set it to 2 mm. This print clearly needs quite a bit of support, but as removing it is always a bit of a hassle, I will change it to just touching build plate instead of everywhere. I will also change the support overhang angle to 75 degrees for the same reason. Slice it again, and as you can see, there's just support generated for this chin area, which is what I wanted. The print will take 22 hours and 37 minutes. I will switch out the filament for this $13 Eryone black PLA and then start the print. The print had no issues except for the area with support. The support didn't stick well, probably because of the small contact surface, and ended up breaking off and falling entirely. However, all we need to do is trim off this filament or shave this excessive beard that Spiderman now has, and the print still looks nice as a whole apart from the chin area. Next, I will print this Chrysler building by Mini World 3D using Eryone Rainbow Silk PLA. I resized it to 295mm and it will take more than 17 hours to finish. The tip may be a little tough for other bedslinger printers to print, but let's see how the SV05 does. Surprisingly, it printed perfectly. I can't see any issues from bottom to top. The tiny tip is printed very nicely, and so are the details of the body of the building. As this printer is printing well so far, I will try to tough print the Eiffel Tower using the same filament and the same settings. I've printed this model on a stock Ender-3 Pro and Ender-5 Pro, but neither could finish and clog the hot end when handling this type of model, which requires a huge amount of retraction. Let's see how this SV05 does. It managed to finish the print, and I wouldn't say it's the worst or the best I have ever printed. The direct extruder can finish the entire print without clogging, but the single gear is showing its weakness as there is a lot of stringing. The result is not as good as the one from the Ender-3S1, but it is still in line with other single gear direct drive extruders I have tested. Now, using Overture Orange ABS, I will print a shelf bracket. I will try not using glue and just printing with ABS as is to test the magnetic sticker sheet print surface, as this kind of print surface usually sticks well to ABS. The result is pretty great. The corners did not warp at all, and the layers are beautifully printed and very even. I can't find any issues with this shelf bracket, and I would say it's a perfect print. The fact that an open printer like this SV05 can print ABS with this result is actually quite impressive. Then, I will print a blink camera sync module holder with this $12 Eryone white PETG. There ended up being more stringing than I would have liked, but the part is still functional and doesn't have many problems. This blue outlet plate was printed with ASA, so the holder might look better if it was printed with the same material, and I wanted to try printing with ASA on this printer anyways, so let's reprint the holder with Polymaker blue ASA and see if it looks any better. This time around, there's noticeably less stringing, the part is functional, and definitely looks nicer with the outlet as well. After that, with Eryone transparent blue TPU, let's print a doorstop. I've printed a few doorstops made to be stuck on the wall with this filament before, but this new one is meant to be installed in the floor. The result has a fair amount of stringing, which seems to be a recurring issue with the single gear extruder, but it is a nice print, pretty flexible, and will still serve its purpose. Following this, I wanted to try printing some high temperature filament, so I tried changing the heat break from the original one with the PTFE tube to a bimetal heat break. This bimetal heat break is just a basic one from Sovol that only costs a few dollars. However, the heat break and the heater block were fastened very tightly to each other and I couldn't take them apart, so I just switched out both of them and added a $1 hardened steel nozzle as well. Other than that, we also need to edit the firmware using Visual Studio Code. First, open configuration.h and search for max temp. The current maximum temperature is set to 275 degrees, which means you can only actually print up to 260 degrees on the printer, as the firmware only actually allows you to go 15 degrees less than the maximum temperature you set. I will change it to 300 degrees, which still means that it can only really print at 285 degrees, but that should be good enough for most high temperature filament, Additionally, I only have one extruder out of these 8 extruders, so I just need to change the first one. But it doesn't really matter, so I will change all of them. Save the file, compile the firmware, copy it to the SD card, and upload it to the printer. You can see that the maximum temperature can now reach 285 degrees. So, I will now try printing with GD Tech PA12 nylon carbon fiber. 285 degrees should be fine. As nylon usually only sticks to itself and to glue, I will change the print surface to a smooth PEI print surface and apply some glue. Printing nylon carbon fiber can be kind of toxic, so I will use the Comgar smoke purifier and move it very close to the print head, as it only has a 40-watt fan and the suction power isn't super strong. Here is the result. The layers and pretty much everything about the print look fantastic, and though I honestly wasn't expecting this printer to be able to print so well with this tough material, it did. Now, for more of a challenge, I will print a larger model, a spool holder, with the same filament and settings. Every layer is printed nicely with very smooth extrusion from beginning to end. As a whole, this is a beautiful print. However, as it was printing, I did notice a problem with this spool holder setup at the top. Particularly if your roll of filament is new and full and stiff, like this roll of nylon carbon fiber, when the y-axis moves backwards, the force is going to push back onto the filament and make some of it pop right out of the spool and get in the way of things. So, I will design a simple filament guide in Fusion 360 and use it to try printing with another tough material, the Polymaker PA6 nylon glass fiber. The result looks pretty nice overall, and I have no complaints. Now, the filament can run through this guide before entering the extruder. The force from the y-axis won't push back into the rest of the filament and pop some out. Okay, after doing quite a lot of test prints with different filament, let's talk about the pros and cons of this printer, starting with the pros. 1. It prints just as well as the Ender-5 in terms of layers, and it prints even better with a direct drive extruder. 2. The hot end is easy to upgrade. With just a few dollars, you can upgrade it to a bimetal heat break and hardened steel nozzle, which allows you to print nylon carbon fiber, glass fiber, as well as other high-temperature materials. 3. It prints quite well with materials like PLA, PETG, TPU, and even ABS with a stock setup. Especially when printing ABS, the quality is very impressive for an open 3D printer without an enclosure. After the simple heat break upgrade, it also prints nylon carbon fiber and glass fiber really well, much better than what I would expect from a $299 printer. 4. The heated bed is supported with 2 arms. It's sturdy, and I can't see any issues with the stability of the print bed, even though it's a single Z-axis. 5. The cable management is slightly better than the Ender-5 Pro, but I will talk more about this in the cons section. 6. For the screen, I actually like this classic LCD screen better than a touchscreen with a badly designed UI. For this type of LCD screen, you can add any features you want by recompiling the firmware, and you don't have to wait for the manufacturer to release firmware updates. Now for the cons. 1. It still uses a single gear extruder. It prints well most of the time, but some prints that require an excessive amount of retraction like the Eiffel Tower show the weakness in this single gear extruder. As the price difference between a dual gear and a single gear is pretty much nothing, this kind of outdated Ender 3 single gear extruder shouldn't still be used. 2. The cable management has improved compared to the Ender-5 Pro. They use the plastic channel for the cables to run through, which is a simple solution that does work, but the heated bed cable is a bit short if you let it run through this channel. The wires are also just soldered on the heated bed, and they don't look super secure to me. Adding a few inches in length to the heated bed cable and using a strain relief connector would be much better. 3. The filament holder was supposed to be mounted at the side, but I don't want it to occupy extra space at the right as it is unnecessary. I also don't like how it uses a Bowden tube to feed the filament to the extruder. I ended up mounting it at the top and adding a filament guide, and it works great. In conclusion, this is a very solid printer. If you spend an extra few dollars to upgrade it to a bimetal heat break, it can also print nylon carbon fiber with good results. As for the price, it's $40 to $50 cheaper than the Ender-5 Pro, but you get an extra CR touch, a direct drive extruder, and some other minor improvements. So, if you prefer a box frame printer over a bed slinger, other than the Ender-5 Pro, you should definitely take a look at this Sovol SV05 as well. They are basically the same, but this SV05 has more features, is cheaper, and prints better. I put the link to this printer under the description. That's it for this video. If you like this video, please do like and subscribe to my channel and press the bell icon to receive new video updates. I will see you next time.